Welcome to Elemental Fun, a historical and cultural look of the elements of the periodic table. Hello and welcome to Elemental Fun. My name is Grace.
My name is Cindy.
And if my voice starts to sound weird or I sound like a man,
Very manly.
that's because I've been losing my voice all week.
She teaches lots of little kids.
It's very fun. But they get really, really sympathetic when you don't have a voice.
Aw.
And they're like, everyone get quiet for Mrs. Castle. And I'll say, oh, you have to get really quiet so you can hear me. They all go, oh, okay. And they all get really close and they sit really close. And if someone talks, they go, shh, Miss Castle's losing her voice.
Can you do that every day then?
I kind of want to experiment with that.
See?
But I think I'll like all of a sudden talk loudly and they'll be like, your voice is
Oh,
back.
yay! Now we can be
Like,
as loud as we want. Party!
Dang it. So today we're going to talk about aluminum.
Like my water bottle.
Oh, your bottle is made of aluminum.
It is.
If you are from Britain or Australia, you know it as aluminium. And we'll talk.
Well, where's the IUM?
Oh, should we jump right
Oh.
into that?
I don't know. Well, let's start with that it comes from the Latin alumen,
Yes.
which is alum, which is potassium aluminum sulfate.
It means
Or bitter salt.
bitter salt.
Yes.
Yes. So if you're an alumni, does that mean you're bitter about it?
Depends on where you went.
Or how much debt you have?
Yes. That too.
So
why does
aluminum-
it have aluminium?
Well, first let's talk about discovery.
Oh, 1825.
Yes. Well, first Humphrey Davy tried. He tried to isolate it, and he couldn't figure it out.
I didn't see that Humphrey Davy did.
Oh, he didn't.
No, because it was he
He was-
used something else. It was because it was the end of the 1700s that they knew about the aluminum oxide, and they knew it contained a metal, but they couldn't extract it because they couldn't use Humphrey Davy's electric current method as he
Like
did
he
with
did-
sodium and potassium.
Right.
Right. So then Oersted came along.
Right. But it's because of Humphrey Davy that it was named aluminum.
Oh.
But then, hold on, let me find my note. So he called it aluminum, but then the International Union of Pure and Applied Chemistry corrected it and said, no, it needs to have an IUM,
Oh.
like
'cause
the
many of
other
the other elements, yeah.
do. And so they started calling it aluminium. But then the American Chemical Society
They're like, "That's stupid."
resurrected the original spelling that Davy gave it in 1925. And what's
Oh.
funny about that is, like, I didn't realize people in Great Britain and France and Europe and in Australia call it aluminium until I was in Australia.
You're like,
and
what are you
someone
talking
pulled
about?
out aluminum foil, and they're like, I'm
Aluminium.
going to put some aluminium on it. And I was like, I'm sorry, some what?
Excuse me.
And they're like, aluminium. And I'm like, no, I think you mean aluminum. They're like, oh, you crazy American with your way of
Crazy
of talking.
pronunciation.
I'm like, but seriously? And then they spell it IUM.
Oh, I guess
instead
that
of
makes
UM.
sense if it was
So that
yeah.
fourth syllable has been
aluminium. Yeah.
has been taken out of ours, and I thought it was maybe kind of the old reason where, like in the United States when we first started the printing press, and
It's
we
cheaper.
would it would be
Yeah.
cheaper to take out letters.
You can still figure out what the word is. It's
Yeah,
done.
right. That's like why color has no U in it here.
Wait,
and it
everything
does-
doesn't have a U in it?
Right. They're like, we don't need that to know how to say it. So, but no, it's because of that. Although in
Oh,
the book
interesting.
Periodic Tales, they're like, no one really knows why. I'm like, well, my app told me why.
These other people did, but
Somebody knows why.
yeah, interesting.
Yeah.
Well, Oersted, yes, he was from Hans. He's Hans Oersted
He's from
Copenhagen. Yes, Denmark. Yes. So he heated aluminum chloride with potassium and isolated it, but it was impure.
Yes.
So then the German Friedrich Wöhler in 1827 perfected it by using sodium instead of potassium. But what's interesting is that, which I didn't know about this, is that it took a while to bring the price down because it was really hard to extract.
Yes.
So for a while, it was more highly priced than gold.
Yes.
And Napoleon III in 1848 served food on the proudly served
Only
food on
for
aluminum
the best
plates.
guests.
Right.
And his son had an aluminum rattle to
Oh, that's
show.
right. Mm-hmm.
And
So
yeah,
how good it was.
it's really funny because it really was so such it was considered a oh no, words are gone. Like a valued metal.
Yeah.
A precious metal.
Oh yeah. It's
And then it's funny because in Periodic Tales, which is the book we based our entire podcast on, not really, but the idea
Kind
of
of,
it.
yep.
Hugh Alder C. Williams, his chapter on aluminum is called Banalization, because like it went from being like really great.
to being like meh,
yeah,
so
like
basic.
it totally became basic.
So basic in today's words.
No, it's well, so yeah, because the people that actually patented the way to
Oh yeah, it was French engineer Paul Hérault and Oberlin. And an Oberlin chemist graduate Charles Hall. Is that a baby?
that is a
It's
baby.
a baby. Somebody's waking up. We send in the cavalry. So what's interesting is they both independently invented the commercial way to get it.
Yeah, it was like a patent race
Mhm.
to see who would get it done first.
And so it's called the Hérault Hall process, where they
Right.
take aluminum oxide dissolved in molten cryolite, which is the mineral, I think, and then electrolytically reduced to pure aluminum. But it's very energy intensive.
Yes.
And there's another option. You can do the Bear method by some guy named Bear, and you do it from bauxite ore
pretty
instead of
Bare bones, would
yeah.
you say?
So, 1887, Carl Bear.
Yeah.
Yeah.
Well, and Hall's assistant was his older sister, and he did it in
Ooh.
like a back shack.
Nice. As good chemistry.
He was
is done.
22 years old too.
Ooh,
Which is,
smarty pants.
Yeah, right.
Oh, you can see it makes sense.
so
He's a graduate student. Yeah.
It went from being like Napoleon. So let's see. There was a dude named Henri Saint Clair de Ville in Paris. He kind of came out with this breakthrough idea of silver from clay. They called it because of its sheen. They called it silver from clay. And he
It's a silvery white, soft, malleable, lightweight metal.
Right. So he presented. I'm just gonna read straight from the book. DeVille presented a clutch of little ingots of aluminum for the first time at the Paris Universal Exposition in 1855, where they were admired by the Emperor Napoleon III, who promptly gave his financial encouragement to the chemist. The metal was then priced at 3,000 francs per kilogram
Phew.
and worth a dozen times its weight in silver.
Dang. Although it's kind of lightweight, so
Yeah, well,
not
that's
as good.
no, that's a valid point. But then I guess Napoleon really tried to make armor out of it. He was really like
Oh.
trying to make armor.
That's not the greatest probably use there.
Because it cost so much to extract it, it really wasn't worth it. He didn't.
It's also
really
soft.
He really didn't. Yeah, it's got to be an alloy to make it really
Yeah.
work with anything. So he really wanted it to be this kind of like industrial tool, and he kind of never lived
got
to
there.
see its potential.
In ancient times, it was used in hide tanning, first aid, fabric dyeing, fireproofing. They found it in the tomb of Chao Chu,
Yes, I read
the
that too.
3rd century Chinese leader. There's something in there that's 85% aluminum, but they have no idea how it was made.
I know, because
cool.
here's the thing. Aluminum is the third most abundant element in the earth after oxygen and silicon. But it's never found by itself.
By itself, yeah.
It's
the most abundant metal in the Earth's crust, or the second most.
Oh.
I saw some conflicting views on this
Okay.
between my two sites.
Second or third.
But they both had it at 8.1% in
Yes.
the Earth's crust, so
Yes.
I'm not sure which one that is. But yeah, it's rarely found uncombined in nature. It's usually in the minerals, bauxite and cryolite, which is where they get it from when they get the pure stuff. These are also called aluminum silicates.
Fun fact about bauxite. The largest producer of bauxite in the world is actually Australia.
Yeah.
And it's such a big deal that there's a special stamp made after bauxite.
Well then.
Is made for it. So I just thought that was kind of funny.
Interesting.
Um,
Do you know? So we're talking about the. I guess we'll just go right into how it's made then, before we go into uses.
sure.
That 5% of the electricity generated in the U.S. is used in aluminum production, which seems like really high amount. I mean, 5% is not a big amount, but when you think about it in the grand scheme of like what it's all used for,
Well,
just to extract aluminum.
So it takes a massive amount of energy to refine, but you could just recycle cans, and it saves up to 95% of the energy required.
Yeah. So what's great, so because it doesn't readily corrode, which is one of its big
Right.
benefits,
Mm-hmm.
it can be easily recycled. And it's one of the most valuable recyclable materials.
I'm drinking out of a aluminum can right now.
My water bottle is aluminum. Yeah, so recycling aluminum needs only 5% of the energy of extraction from getting new aluminum from ore.
Mm-hmm.
But in 2012, only 55% of drink cans made it to recycling bins,
Come on,
which is
people.
just crazy because like this is so. This really mind boggled me when I was reading it. I'm like, this is super easy to recycle. It's the best thing to recycle. Why aren't we making more things out of aluminum? Because what is it? 75% of all aluminum ever made is still in use because of recycling.
Okay.
So I mean, like, if we were able to fully recycle like 100% of the cans that we
Would
have,
you say
like
that
we wouldn't need to.
people aren't so big on putting it in everything because of kind of the it hasn't been totally proven, but kind of aluminum's bad, right?
I haven't heard about this aluminum's bad.
It's toxic to plants.
Well, yeah, to plants, but it
But-
doesn't like leach off of your things.
No, but so it plays no role in our body.
Right. So there's no known role in our body. Yes. The aluminum.
But it reduces
One of
crop
the
yields each
aluminum
year.
ion is soluble and toxic to plants, and half of the arable land is acidic, and that speeds up the release of the aluminum from the minerals it is in, so the crops absorb it, and you get lower yields.
Yes, but it also people think that aluminum is a risk factor for breast cancer and even Alzheimer's.
So it says it can accumulate in the body, and there's a link with Alzheimer's, but Alzheimer's,
Alzheimer's.
but it has been suggested, but has not been proven.
Right.
Because there's some other things that have also been linked to
And
possibilities
we'll talk
for
a little bit
Alzheimer's.
about after we're doing a couple of different podcasts about things like BPA, and we're going to do one about aluminum in our deodorant
Mm.
and the link they are kind of finding with it, and our bodies can't really get rid of aluminum very easily.
Well,
though.
we don't really absorb it. So we absorb very little of the aluminum that we eat. So there are above average amounts of aluminum in things like tea, processed cheese, lentils, sponge cakes in the raising agent.
Right.
And cooking in aluminum pans does not give you more aluminum in your diet unless you're cooking something acidic, like things like rhubarb that it
Right.
might leach into. Some indigestion tabs are pure aluminum oxide.
But can't that triple the amount of aluminum in your body? I read
I'm
that
not
it
sure.
Could, by those over-the-counter antacids, it can tenfold your amount of aluminum.
I suppose
in your
it
body.
could if you are taking them a lot.
A lot.
Yeah, like consistently. I think that's really probably the biggest thing, because I have not really heard a lot about aluminum poisoning or anything like that.
I do know that my sister had her son's blood tested, and he had high amounts of aluminum, so she got rid of things like baking sheets with aluminum and
Right.
things like that to just kind of minimize any exposure to it.
Interesting.
But I don't know.
I don't know. That yeah, I'm not sure, because it's a fairly common, especially for water bottles and things like that. But the
And
cans,
it's non-toxic to us,
right?
That
I mean,
we know of.
That we know of, yeah. Well, this is back up what we just said.
Hi, lead.
But the what's cool is that recycling is really, really fast. So a can be recycled and turned into a new can in as little as 60 days. So just from that fact of like,
I've actually seen videos on YouTube where people melt down cans
Mhm.
and then like
And
put them into a
rebuild things.
mold and then make a sword.
yeah, it's pretty crazy what you can do. The top of the Washington Monument is an 8.9-inch aluminum pyramid for the
And you know
lightning
what's
rod.
funny about that?
But they needed to add copper because
right,
it
it
didn't, do
didn't
it.
work as well.
It didn't
I
work
know,
as
they're
intended.
like, oh, this isn't work. It's not
Oops.
as conductible as. And that's the thing is like we started replacing it with like instead of copper in a lot of
No,
things.
it is much more conductive than copper.
I thought it.
No,
There's
that's why.
something about it that doesn't work.
No, it's a good electrical conductor, and it's cheaper than copper.
It's
And weight for weight, and almost 2 times as good of a conductor.
Uh,
So a lot of houses actually are switching to using aluminum rather than copper.
but then why did it not work at the top of the Washington Monument? And they had to add copper.
The aluminum wasn't strong enough to stop the damage. So if it got electrocuted, like the aluminum is good conductor, but it's not, as we just talked about, it's not good for armor and things like that. It's a soft
Right.
malleable metal.
Yeah,
so
actually, they were using. Great Britain was using aluminum in ships during the Falkland Wars in 1892.
Mhm.
Or, sorry, 1982, against Argentina. But then, like missiles would hit the ships, and they'd be like,
Boing.
"Ow!" So they
Ow.
stopped using aluminum in their warfare. But about the Washington Monument, what's funny is I'm actually reading Bill Bryson's uh, brief history of
Oh, the brief history of everything.
nearly
Mhm,
everything
yeah.
or something. I read it while I rock Charlie to sleep. That way I can only read like a couple of pages at a time. But he was all like, "Oh, they put aluminum on the top of the Washington Monument to show our prosperity and things like that." And then, but then Periodic Tales was like, no, Bill
No,
Bryson, that's not why they did it." But
It's because it's a giant stick in the air that wants to get
He
electrocuted.
calls him out on it. He
Oh,
calls,
that's
like,
it's directly out on it.
Yeah.
Interesting.
Alder C. Williams calls Bill Bryson out. Like, yeah, that's
Yeah,
a nice
no.
whimsy, but that's not really why they did it.
Well, I'm not gonna be right about everything.
I guess not. Especially, except us. We're right about
Really? Always.
all of our research is totally.
Totally spot on.
Totally
Everything's perfect.
Yeah.
Let's see. So we'll just go into uses
Sure.
since we've done
There's
all
only
that.
a million of them.
I know cans, foils, kitchen utensils, window frames, beer kegs, airplane parts. Because of the properties. So it's low density.
Yeah.
So low mass per volume. So it's lightweight. It's non-toxic.
Yeah.
Has high thermal conductivity.
Yes.
Excellent corrosion resistance
Yes.
because it doesn't rust like iron.
Yes.
It's easily cast. It's machined and formed because it's very malleable.
Mm-hmm.
It is non-magnetic and non-sparking, and is the second most malleable and sixth most ductile metal. And it so what's interesting though, is it doesn't basically rust like
Right.
iron, but it can oxidize. Which is losing electrons. That's
But
what.
doesn't it like make an oxidized like
Right.
layer?
So it sticks on it, like it get oxidized, and it goes and just like lays over it. So then it insulates everything from the rest of it from getting.
So it like
What?
heals itself.
Yeah, basically.
It, like makes itself its own blister wound.
Yeah, and then it just looks still like silver.
Yeah.
Silver color. Yeah. But it is most often used, as you alluded to earlier, in alloys because aluminum is not strong but
Right.
light. So if you combine it with super strong metals
Mhm.
like copper, manganese, magnesium, and silicon, you get a lightweight and strong. So this is what is used for a lot of airplanes and other forms of transport because you don't want really heavy things. That's always the thing when they go, "Whoa, the black box. Why don't they just make the whole plane out of a black box? If the black box survives a plane crash."
It's like,
Well,
'cause the
'cause
black
it's
box is
really heavy. And it's not feasible to make that out of the entire plane.
People,
So,
people with their reasoning.
but they were saying somewhere I had in here that basically the flight and our ability to go into space is due to be aluminum, because otherwise everything would be too heavy.
And what's funny is they used a lot of aluminum in space travel with the first astronauts.
Mm-hmm.
They packaged all their food in aluminum
Oh,
containers.
mm-hmm. A Boeing 747 has 147 pounds of aluminum.
Yes. Or aluminium.
Aluminium. And speaking of containers and packaging, in 2012, 1.9 million tons was used for containers and packaging. 1.7 million for appliances, car parts, and other durable goods. So, yeah, it's used in a lot of different things.
Yeah.
So it's and we already talked about the fact that it's a good electrical conductor, so it's actually better than copper.
Mhm.
What's interesting too, so when you evaporate it in a vacuum, because as you do,
Yes,
it just has a vacuum.
I always
you know.
evaporate
Mhm.
my things in vacuums.
It forms a highly reflective coating for light and heat,
Mm.
and it does not deteriorate like a silver coating would. Like your stuff tarnishes. So they use it in telescope mirrors, decorative paper, packages, and toys and things because it's always reflective.
Yes. That's funny.
But it can be reactive. So this is one where you should not do unless you have a fume hood.
I got
Don't
a
do this
fan
at
above
home.
my stove.
No.
Does that count?
Fume hood.
That's not a fume hood.
No.
But
Well, I think they mean like chemical fume hood.
okay,
Nice.
fine.
Real ones.
I won't.
But if you take aluminum powder and iodine and a few drops of water, you get a toxic purple iodine vapor and then a sudden flame.
So purple haze.
Ooh. So that's when it shows that like it can be reactive. It's not completely inert as
You want to know something cool
Thanks.
about aluminum, though?
I do. Tell me.
Did you know that thanks to aluminum oxide, we have some of our favorite gems,
Gems?
rubies,
Ooh, really?
and sapphire?
What is this?
So, rubies are aluminum oxide with traces of chromium in them.
Oh, because
But-
the way the different metals give the different colors.
Yeah, but if
Right.
it's not chromium, if it's iron and titanium, that's what makes sapphires.
Ooh.
Yeah.
Interesting.
So, thanks, aluminum. You're so shiny
It's so shiny.
and colorful.
Beautiful.
It's not you being colorful.
Well, the combination together.
Yes.
Yeah. Cool.
Yeah, I didn't know. I
Interesting.
didn't. I always, you always wonder as a kid. You're like, what makes rubies and diamonds? And
Yeah, those different
jewels,
colors.
and you're
Yeah,
just
good.
like aluminum oxide.
Just different combination of medical compounds.
Apparently,
Metal.
I heard. I
Medical.
didn't hear medical.
I said metal.
Yes,
I don't know what anybody else heard.
I think you're saying metallic.
Metallic, yes, perhaps. I haven't slept very well. I'm 8.5 months pregnant, so sleeping's not
Why
so
aren't you
great.
sleeping well?
I don't know.
I don't know what that's like. I have an 11-month-old.
I will actually be happier when I have the baby because at least the small amounts of sleep I will get, I will actually
You'll be
be
comfortable?
sleeping. Yes. Yeah.
Oh.
We'll see. I'm hoping it's gonna be like Benjamin, and he slept through the night in like 8 weeks.
I'm telling you now, that's not going to happen.
Hey, looks, ma'am, it happened with Ben. It happened
Charlie
with Ben.
finally slept 7.5 hours straight last night. That was the first time.
Yeah, I'm going with he's gonna
The
be like
week
his brother, or she's gonna be like his brother.
week
Her
before?
brother. Yeah.
He slept no more than 2 hours straight without waking up.
Right, but also
I
you
could smell
you haven't
colors.
you haven't had to have a crawling baby before the age of 1.
Charlie crawls now.
Okay. Well, then he made it. But still, most
Barely.
people only get like 6 months of non-moving baby time.
Oh, that's
You've
true.
lucked out on that.
My babies are like,
screw that
you
moving.
hold me all the time. Why
Yeah.
would I crawl?
What's ridiculous?
Tell me I'm stupid. Just pick me up and carry me to where I want to go.
I would go over there. Send me there. Oh man. Okay, back to aluminum and
Oh,
aluminum.
what are we talking about?
I don't know. You want to know where it's formed? It forms in the stars.
Of course, just
Yeah.
like everything else.
Magnesium picks up a proton, and
Yeah, they're
the number of protons in an element is its identity. So if you
Wait.
change the number of protons, you change it into a different element.
Does that mean magnesium's number 12? Number 12? aluminum's number 13?
Magnesium. I'd have to look at my periodic table because I don't have it memorized.
You don't. What?
I know.
Don't have it memorized?
What's wrong with me?
Unlike me, who.
Yes, magnesium is number 12.
Ha ha ha.
So if you add one more, you now get to 13, and you're aluminum or aluminium. So it does that. And so there are other. Remember we talked before about other isotopes, so ones that have different number of neutrons,
Right.
how heavy they are.
Yes.
So most of the aluminum isotopes are actually quite unstable. So their half-lives are milliseconds. So
Ooh.
how long it takes to go from like 1 to 5,
So it's
0.5
basically
to
like the bottom half of the periodic table.
it's like, yeah, exactly, those new ones. But one stable one, aluminum-26 isotope, has a half-life of 750,000 years.
Whoa, that's a long time.
And that is found in stars forming
Oh.
regions. So what's really cool is
How do they know that they find them in stars?
because they found bursts of these and they detected them in space.
Oh,
And so then they're allowed, that makes them pinpoint supernovas
okay.
using those like fingerprints.
Space is so baffling
It's
to
so
me.
crazy. I
It's-
can't, it hurts my brain.
I can't, it really hurts my brain. I'm reading Bill Bryson, and he simplifies things, and it still hurts my brain.
It's still, I just can't get over the fact that it doesn't end. I'm like, something has to end. I don't understand. But what they did with that too is they looked at it and said that a supernova happens every about 50 years on average in the Milky Way, and every year there are 7 new stars being born, and they can do that from the aluminum isotope 26.
Interesting.
Isn't that cool?
Yeah.
So aluminum's good for something besides everything.
We use it everywhere.
Everything.
We have found uses for. I mean, think about it. They are on your windows. They are on your roof. They're also in your baking sheets and your pots and pans, and they are found in your water bottles, and they are found in your silverware. It's not silver. Your ware is not silver,
Well, it used to be silver, but yeah.
but it has a.
My silverware is actually silver.
fancy.
This is my grandma's silverware. Mm.
I don't know what mine is.
Yeah. Most people's are.
I'll have to call my grandma. She gave it to me for my wedding.
Mm. Excuse me, Grandma. What is my ware made of? Is it silver? Or is it aluminum? Aluminum. But so it is the most easily recyclable. But do you know? Are you allowed to recycle aluminum foil?
Only if there's no food on it.
Right. So, but you do have to be careful because some places won't take it, like at all.
Does our place take it?
I don't believe they do.
Whoops.
I don't think so.
I better
Yeah.
take that out of my recycling bin right now.
Yeah, I gotta check that. But I think because I was always like, yeah, aluminum foil that goes in. It's foil. But some places don't. But what's interesting is that you can recycle it, but it has to have no food because the food gets on the stuff and then contaminates it and can
Don't
get
you
all.
think like
crap.
it's cooked at such a high heat that the food would just burn off? I mean,
Well, it's like grease and stuff though. It's gonna get
Ah.
that stuff gets on there and it's not. So it's I wrote that. Oh yeah. So it has to be cleaned and not mixed with other materials. So it can't be like yogurt tops and paper in
Right.
your paper boxes and stuff. So you have to check if your recycling program accepts it. But I had always assumed once I heard that you couldn't recycle it, I was like, oh, you just can't recycle it. Not realizing, oh no, you can recycle it. And imagine how there's a ton of stuff that gets thrown away, like tons of it that gets thrown away every year,
yeah.
which is so silly now because it's so easy to recycle and so energy intensive to extract it
Well, I remember as a kid, so like a long time ago,
in a galaxy
children,
far, far away.
called Spokane. We would go to a recycling place with our bag of aluminum cans,
Mm-hmm.
and I'd get like a nickel for
Oh yeah.
everyone.
Mm-hmm.
And I'd get so excited. I'd be like,
Woohoo.
oh, I'm making money. And then one time they paid me in a $2 bill. And I was like, this is the best day
If
of
someone
my
paid
life.
me in a $2 bill, it'd be the best day of my
It
life
was
right now.
the best day
So
of my
cool.
sad little Spokane life. Was
But then
being
you can
at
never
the
use it
recycling
because I got
plant.
that was before I got a $2 bill and I'm like, I can't ever use this. This is too cool.
Right?
I'm not gonna use this
I
$2.
actually don't know where that $2 bill
Oh, shame on you.
is.
No, they used to have recycling programs that would pay, and you say it says like 5 cents. A lot of times, they'll say 5 cents California, and
Yeah,
and
yeah, they have a bunch
some
of
I
stuff
think
on
like
it.
over in the East Coast too. I think.
I think New Jersey's one of those.
Yeah, New Jersey is one. But yeah, so it seems like that's a big waste thing. But I think part of the problem is one of the main things with recycling, whether it's plastic bottles or aluminum or stuff, is that it's the contamination issue, and that
Yeah.
even if you tell people to rinse it out,
They're not going
not
to.
everybody does, and they just want to throw it in with the stuff. So then it gets contaminated, and then nobody wants to take it, and then we're where we are now, where China won't take any of our recyclables, and they're sending them back, and yeah,
It's
not good.
great.
Awesome. So the rule is rinse off all your recyclables, please.
Yes.
Otherwise, you contaminate it, and then it won't get recycled, and then they just go into a landfill, and that's dumb.
It's really dumb.
Yeah, especially with how expensive it is to pull aluminum out of the ore
Right?
in the first place, and it's so easy to
It's still
recycle.
expensive. Like it's gotten
So
cheaper, but
easy.
it's still expensive.
Yeah. I have a couple more fun things.
Sure, that's all I got on mine.
Okay. So in 2011, this guy, Dan Schechtman, Schechtman.
You did a really good job with that name.
Thanks. He won the Nobel Prize because he discovered quasi-crystals.
Quasi-crystals.
Don't know exactly what they are, but it's a molecular structure of non-repeating patterns in manganese and aluminum mixture.
So aluminum
Something
was
new.
part of the Nobel
Yep, in 2011.
Prize in 2011. I almost said Peace Prize again, but I didn't.
Peace
I
Prize,
stopped
not
myself.
peace. In 2010, Yuntian Zhu,
Again, good job.
thank you, from North Carolina State University, made an aluminum alloy as strong as steel.
Mm.
It was aluminum with magnesium and zinc. And if they put it under really high pressure, the aluminum basically it crushes the aluminum to like nano size, and then it makes the alloy be able to move but not be brittle. So a lot of the alloys that they have get really strong, but then they're so strong that if you bend it too far, it just breaks.
Right.
So this allows the aluminum this alloy to move a bit,
Malleable.
a little bit malleable, but
strong.
flexible, but still be very strong. But they can only make it in very small quantities at this point. So
Come on, 2010.
yeah, not as
10 years later. Let's get this done.
yeah. It's yeah. Well, I mean, maybe they have. I don't know. Haven't heard anything about it. A lot of those things, they find that they can do it and then realize, well, it's not really as
This
useful.
is so cool. And they're like,
well,
never
it's like
mind.
Napoleon, right? Like,
Yeah.
oh, this is gonna be the greatest thing ever. Oh, this is kind of hard. Okay, just kidding. Sorry. Yeah, I think that's all we got for that. So aluminum's cool. It's lightweight, soft and malleable, and used to be really.
It's not
really
toxic, kind
of toxic for plants,
Possibly for
but
us.
Possibly.
It has been proven though to be a notes. To be a neurotoxin though.
Well, I mean, I guess to say because like heavy metals are all known to be bad,
Right,
and aluminum's
and
not necessarily heavy, but still could be a lightweight toxic thing. Yeah. But I would think with how much that we have that it is everywhere.
Yeah.
If it was really a problem, we would have been seeing issues by now.
I think that maybe it takes a large amount.
Well, and I think a lot of it too, because it's not one that leaches out
Yeah.
easily. So again, if you're cooking in it, it's fine. But if you're
Unlike
cooking in
BPA,
acidic things,
in case you're curious,
right?
listen to
Check
our
out the BPA
about
podcast.
BPA.
But since it doesn't leach like that, even like the plastic does out of the BPA and stuff like that.
Yeah.
So, I think that's where it's less of an issue.
Yeah.
It's because if you're drinking water, unless you're drinking acidic water,
No
Like-
rhubarb water out of
no
your
rhubarb water, definitely not.
Wonder if they make rhubarb water.
I don't think that would. Your rhubarb's so tart. Why
It
would
is
you want to
pretty
do
tart.
that? I mean, I'm
What
not a
do you
tart
think
person
Grapefruit.
because they're weird,
I like.
and you're weird.
Okay.
I don't
Says-
drink grapefruit, and
says
I am
the-
weird, but
Says the woman who doesn't eat anything except peanut butter and chocolate.
that's not true. I don't eat anything acidic.
That's true.
I like many other things. But there's a reason for that. But we can do that in another episode.
Yes, we can.
Okay. So I think that is it for aluminum or aluminium.
Depending on where you're from.
Yeah.
Or if you want to sound fancy and confuse
Fancy.
the crap out of people, then you call
You
it
said fancy.
aluminium.
And then they just look at you like, what?
Or they think you're just a weirdo.
That too.
So if you have any questions or comments, you can feel free to email us at elementalfunpodcast@gmail.com.
See?
You can find me. I've actually changed my Instagram
That's right.
label to Gracie Runs 50 by 50. That's 50x50.
Used to be Mama.
Run Mama
Yeah,
Run
Mama,
50
yeah.
by 50. And I was like, that's too long. Gracie Runs 50
Gracie,
by
there you go.
50. 50x50.
You don't want to just be a mom too. You can just be.
I could just
you
be Gracie.
Yeah.
Yeah.
Because you're so many things, not just a mom.
True that.
Mm-hmm.
So many things.
And you can find me at Pacific Mammal Research, PACMAM, PACMAM.org, and on Instagram, on Facebook. my
Yeah.
other job.
Your
Main job.
Your main job.
Yeah.
Anything else new going on in your life besides about
Since
pop?
8.5 months pregnant.
Yeah.
Yeah. No,
No.
I think it's good.
Cool.
All right.
All right. Well, yeah. It's been a week.
It's been a week.
It's been a week.
Oh, it's been a week. I was like, wow, that's
It's-
really great for this podcast. This has been a really weak one.
It's been a week.
Well, it was aluminum, so it was a little not as strong.
Good job.
Did
All right. Well, I think that's all for tonight. Again, my name is Grace.
you forget it for a second?
No, I did not.
My name is Cindy.
Stay curious and stay tuned. We'll have more.
See you next time.
Yes.
Talk to you next time.
Yeah.
Aluminum.
Aluminium.
Aluminum.
Aluminum.
Potato.
The dark darkness.
That's your beer.
It's delicious.